And today we are going to discuss about Hadoop MapReduce workflow. So before we try to understand what is MapReduce workflow, let's see what is MapReduce. Most of the time people got confused and they think MapReduce is a programming language to do the programming in Hadoop cluster and to do programming on large dataset. Whereas MapReduce is not a programming language. MapReduce is a kind of programming model. Okay, so when I say model, it means this model can be followed by any language. Any language is following this model adhere to the guidelines provided to generate the MapReduce function can be following the MapReduce programming model. So, and this is not specific to any kind of language. So this model can be followed by any language. We just need to adhere to the flow or the guidelines that specify how you can implement a MapReduce model. So we will see in detail how Hadoop follows this model. Okay. So first we see like how it got invented, how this MapReduce kind of model adopted in Hadoop. Back in 2003, Google published some paper on Google file system and explained how they are like storing the huge information of web and they doing their indexing. So on the basis of Google file system, duck cutting invented the HDFS or what we call Hadoop distributed file system. So this was basically in earlier used by the Google company to store lot of information around the web. So the duck cutting invented HDFS on the basis of Google file system white paper, which they published around 2003. Then somewhere around 2003, Google published some white paper to explain MapReduce programming. In this one, Google explained how they were really processing their distributed storage and the data which were stored in the Google file system. And again, like duck cutting followed that paper and invented MapReduce programming in Hadoop. So this is how the Hadoop implemented the MapReduce kind of model in its framework. Okay. So now map and reduce keywords are not new. If someone has worked on functional programming, then they must have heard these two words because functional programming has been from last 40 to 50 years and map and reduce are functions in the functional programming. So even before Google was really following the MapReduce model, these two functions were already present in the functional programming. Okay, so these are kind of not new to the world, but somehow Google like kind of used it or like made it some meaningful to process their data, and then they published white paper, and on the basis of that, duck cutting like made this MapReduce programming and efficiently fit it into the Hadoop. So it actually efficiently put the MapReduce model in its framework so that the programmer really don't need to worry about how the complete map reducing thing going at the back end, because this is taken care by the framework itself, and the programmer can just concentrate on their business logic and all. So if you know about functional programming, this is basically concentrate more on functions. Like in OOPS, we are more concentrated on while making the objects, but in functional programming, we are more on how to create a function, and function takes input and always give same output or same input. It doesn't change the state of the object. So this is how like the uh, MapReduce concept is taken from the functional programming, but it's not exactly same, I would say, but it derived from that, and it uses the paradigm of functional programming and MapReduce functions while fitting into our Hadoop framework. So in a similar way, when we do the map reduce kind of programming, we really don't want to change the internal state of the object, and that is really required when you are doing kind of distributed programming where you have data distributed across a lot of nodes, and you don't want to share the things between the nodes, right? You want to process the data or the blocks independently across all the nodes and don't want to share anything. Otherwise, if we are dealing in a big data world where we have a data in terabytes and petabytes, if we do some kind of sharing, it will be very, very difficult for the management and how we are going to manage the processing and the data. So same way we are following in Hadoop framework. So now let's see what is map. Map is a function. Map is a kind of function which transform the input and give some output. And again, reduce is a kind of function which do kind of grouping in Hadoop. We will see how does it work and how the framework provides the functionality to implement these two things in a more efficient manner. So before that, like I guess I would need to draw some diagram and show you how the input will flow through it. Okay. So let me quickly draw a cluster and store some file. Node 1, node 2, let's just say data node 1, data node 2, data node 3, and data node 4, and so on. Name node, job tracker, task tracker, task tracker 2, task tracker 3, task tracker 4. And let's assume you have an input file of 200 MB and block size 64 MB, replication factor 1. So let's divide 200 by 64. This data will be stored in floor blocks, and let's say each one is storing one, B1, B2, B3 and B4. Okay. So now first we will see how the overall processing will go, and then we will go into detail how the actual record reading, record writing and the assignment and or the grouping takes place. This client submits the job to the job tracker. Okay, then job tracker will contact the name node for the file information and the blocks, where the blocks are stored and where I need to do the processing. So let's say it got to know, the job tracker got to know, okay, these are the data nodes where my file is actually stored, and each block is of this 64, 64, 64, and I guess last one is less. So now it will give the task to each task tracker. Let's say, because we have the blocks present and we need to take care of the data locality, so it will not assign to the another node where I don't have any block. It will assign where we have a data locality and pass the code to the data, and processing will be done locally. So now I have a B1 block here and I have a 2 map slot, B2 block here, 2 map slots. Now task tracker will start the map process. And important thing is, since we are dealing in a distributed world and we have also the data distributed, you can see the processing is also independent, and these processing or these map slot processing not talking to this map processing, this one not talking to this one not talking to this, nothing is shared. And this is a kind of like what we do in our functional programming. We are things are keeping separate, because when we are dealing in a big data world and we have a lot of data, if we'll try to share some state or share some values, it will be very difficult to manage the processing. Okay, and this is everything is managed by the framework. We really don't need to worry about. We just need to submit the job, and rest of the scheduling, assignment, running the task, and then relaunching, fault tolerance, everything will be taken care of the framework. That's the kind of beauty of Hadoop. So now it came here. Now you have a map task running here on block 1, map task running here block 2, map task running here block 3, map task running here B4. Okay, and each map task output, when we'll get the output, will be stored in local disk of each system. Local disk. Please remember, this is a node, our computer machine. It has Java installed, it has Hadoop installed, and it will have local disk as well, right? Because we installed Hadoop on it. It's not the entire local disk taken for the installation. It will have a local disk also, and in some part there will be, like we do our normal installation, so some part will be allocated or dedicated to HDFS. So let's say if it's a, let's assume 40 GB and 10 GB we have a Hadoop installation. So 10 GB is taken care by HDFS and 30 GB is still with the local disk. Okay, so you have local disk there. This data, the output of map, will be stored in local disk, not on HDFS. Why? Because this is a kind of intermediate data. This is not our final output. So we don't want our intermediate data to be stored in HDFS and have it replicated multiple times, and we are wasting our storage for intermediate output which we don't want, right? So that's why the reason it is stored in local disk, and this is not transferred across network. So here again we are saving our network bandwidth. Whenever we are dealing in a distributed kind of environment, a lot of care needs to be there for, like, we have to save our network bandwidth. We have a lot of intercommunication process. So whenever we are dealing in distributed, we have to take care of these things. Okay, so we want to process most of the things at a local, and we had made it a fault tolerant. So if even if this node goes down, the data is replicated on another, and in a similar way the task can be relaunched on that particular node. So we want to do more and more thing on the same node and without sharing anything across nodes. That's what we want to do in distributed. So now we have intermediate data in local of each disk. Okay, now the map function is done. Now we have a reduce function, and reduce function is a costly affair, because in reduce, since we have to group the result across the mapper, right? So now we need to group the result of this output, this output, this output, and this output. The data needs to be transferred now across the network. That's why it's one of the costly affair. Okay, and and where the reduce function will run, we don't know. It depends upon like how many reducers or reduce function we want to run. It is a configurable property, so you can run one reducer, two reducer, and so on. I am assuming in my program we have run one reducer. So reducer can run here, reducer can run here, 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 or anywhere, because anyhow in my reducer I don't have data locality preference, because I need to move my data now. So it doesn't matter where it runs, it will really depend upon which task tracker reduce slot is free. If this one is free, it may execute here. If this one is free, this one is execute here, because anyhow I need to move my data now. So now before it comes to reducer, the sorting and shuffling of the map output takes place. I will discuss in detail what is sorting and shuffling. This is just to give you an overview. So the sorting and shuffling will takes place in the map output of each node, and all the data will be transferred on the reduce. Let's say here you are planning to run reducer slot. Let's say here framework decided that here it will run. So data will be transferred, and before it giving to the reducer, sorting, shuffling, and grouping also. It will group. I will tell you later like what is grouping. So sorting, shuffling, and grouping will take place, and it will give to the reducer. Now here we have a reducer slot empty. This task tracker has been assigned the task. Now this will run its reduce function, and reduce function is basically a grouping or aggregate function that runs on the groups on the mapper output. Okay, and then whatever the output will be, it will be stored on HDFS, Hadoop Distributed File System, in one of the directory that will be given by the client at the time of submission of job. The result will not be given back to the client anytime. It will always be stored on the HDFS, because we want the result to be safe and secure, and that's why it is a final output. That's why it's stored in HDFS. It will have all the replication and fault tolerance feature. Okay, so this is how, like, just the flow, how the map reduce function will run in Hadoop cluster. So now we will go through a sample MapReduce program where we will see how the MapReduce flow works in Hadoop framework. And in this program, what we are going to do, I am going to, like, let's create a sample file and expecting an output of count of each word in the entire file. Let me create a small file, then it will make you more clear about the input and the output. So let's say I have creating a small file, and the file name is test, and the content of file is apple, banana, orange, kiwi, again apple, banana, orange, berry, grapes, apple, berry. Assuming this is a 100 MB file, 100 MB data file, 100 MB data set. Block size 64 MB. It will be divided into two blocks. Okay. Assume this is your block 1, 64 MB. This is your block 2, 36 MB. Let me draw a little cluster at the below so that more clear. I have a small cluster, data node 1, data node 2, block 1. I have first two lines. Block 2, I have last two lines, and connected to a name node. And name node has information about the blocks where we have the actual file content. Okay. So now what output I am expecting? Output I am expecting is I want to count the number of each word in the entire file. So let's say apple, I have 1, in second line 2, and then 3. I have 3 occurrences, so output should be apple 3. I am counting each word, and this should be my in the output file. Second, banana 1 time, banana 1. Then I have orange 1. I guess here we have banana, so banana is 2. Orange is 1, 2, orange is 2, and so on. So I want to count of each word in the entire file. That's what we want, and we'll go through how the flow in the form of MapReduce will go in Hadoop framework. And this example is a kind of hello world program in our normal Java program. So this is a very standard program, but through this program we'll see finer details how the flows goes through. Okay. So now we all understood block. This is minimum unit of container of storage on data node. So this is the minimum unit of data that can be stored in Hadoop framework, and it is used for storage. Now similarly, for processing we use the term input split. Okay, so block is the minimum unit container to store the data. Processing is the kind of one input split given to each map task. Okay, so and by default one input split equal to one block. So if they have one block, then it will be equal to one input split. And why we have separate representation? Tell you. Block is actually a physical storage. It's a physically stored data content in your data node. Okay. And input split is a logical representation. When I say logical representation, it means let's assume it will just give address from here till here. When assigning the task to the map task, while processing it will tell to the program, okay, you have to process the data from starting position this to end position this. It is not actually a data, it's just representing a data which is actually stored in your data node, and that's called block. But while processing, since we are passing just address or representation, it's called input split. And this is a kind of configurable property. You may even configure two blocks or more than one block in one input split. But if you have one input split, okay, or one input split means this is a unit of processing. So if you pass one input split and you pass two blocks, then you losing the power of data locality, because one input split will be processed by one map task. And if one map task is working here on block 1 and block 2 is here, and you also included block 2 in the input split, then the data has to be moved in this node, which we don't want. So by default, this is the best practice to have input split equal to one block. Okay. So now here is our file test, and we know one block, one input split, one map task. Okay, so one map task work on this block, one map task will work on this block, and these two tasks are independent to each other, no sharing, nothing. Okay, so this is input split 1, this is input split 2. Why we have two input split? Because we have two blocks. Okay, now after the input split, we have record reader. So now this input split is at the back end is actually representing your block, which is stored in your data node, but it is just representing input split. Okay, you have to process these blocks, so this is just giving the address. So till here you can assume where we are now. Till here client has submitted the job with the file, okay, to process. Now job tracker contacted name node, okay, I have to process this file, where are my blocks, and the name node will give information, we have block 1 and block 2 which consists of the file. So job tracker will assign the task here, one task here, one task here, as both has the free map slots. Now the map task will be started, and this is where we are at this point. Once the map task started, this is a kind of internal process how the map will read your data in the form of blocks, and how it will convert the things into key value pairs and so on, and we'll see the complete things. Okay, but this is just to give you a kind of reference point where we are. The map task just started. Okay, and in Hadoop framework, one more important thing we need to understand, it's entirely on key and value pairs. Hadoop framework entirely operates on key and value. Whether it's a map task, reduce task, or any other advanced topics that we study, entire data is moving around the Hadoop cluster in the form of key value. Hadoop only understands key and value. Okay, so now we have input split, map task started, and this is just the first phase, how it is going to read the data stored in the form of blocks. And Just to give you reference, we are using a default input format, that is text input format. There are a lot of formats in Hadoop. This is just the default input format to read the file. Okay, and this is very important format since it's a default. I will tell you how it reads the file, but this is the input format that we are going to study now. Now this is the input split, and now record reader is the interface. Record reader is the interface between the file that is stored in data node and to our map task. Okay, so this record reader is an interface in Hadoop. This record reader is the actual worker node. Sorry, not node, this is the actual worker that will actually read the file or block 1 or through input split one record at a time. This is what the called text input format, to read the file line by line. Okay, record reader is the actual worker which will be doing this task. Okay, and one more thing record reader takes care, record reader respects boundaries as well, because think of a scenario where, let's say, in a block, let's say you have orange, you have OR and A and G, and this stored in block 1 because just 64, like your 64 MB reached and it is got into the block 2, then our records are broken. Okay, so this is also taken care in the record reader interface. Okay, so in the implementation of record reader, since we are using a default text input format, and this record reader will be also the default record reader, line record reader, so it will read the file line by line and it will respect your boundaries as well. It will take care that your complete line is being read and data is not truncated. Okay, and this will be done at the back end. You don't need to worry about record reader for default formats. This is not the programmer job. Okay, this will happen at the background. I will tell you at each step which is taken care by the programmer, which step is taken care by the framework. So since we are using the default format, you don't need to worry about the record reader. Okay, so now it will read the first record, apple, banana, orange, and it will convert. And since we know Hadoop understand only key value pair, record reader has to give the record to map in the form of key value, because map and reduce understand only key value. So what is the format of key value when record reader give the record to the map in text input format? It is the byte offset and the entire line as a value. This is key value. And what is the byte offset? Byte offset is the address of a line in the entire file. So let's take the example for the first line. My key is 0 because it's just the start of the file, and my value is apple, banana, orange. The entire line, entire record is my value. Okay, now how it will read the second record? Let's count 1, 2, 3, 4, 5, 6, 7. So I need to count till last the number of characters and a new line, and my next line starts from some characters, let's say 30. So now byte offset is 30 and entire line as a value. This is my entire input to the map, because I consider only 2 lines, but there may be multiple line and multiple record, right? And same will go with the input split 2. It will read like we stopped at 30, then again we need to count 31, 32, 33, 34, 36, whatever. Let's say it reaches 50, then key value will be 50 an entire line. And let's say next address is 70, the entire line. This is my entire block now. Okay, and one thing also note here, this byte offset is at the global level. It is a kind of global variable across the file, and this is the main thing that is being used by the Hadoop framework to construct an entire file from the blocks, because this is the only variable that we are, which is global, right? Global across the blocks, which is stored along with the blocks. Okay, so now we have a key value pair, and it will pass to the our mapper or map function. Okay, and one more thing, like once it passed the first record, let's say 0, an entire line, the map function will start at the same time. It is not going to wait for record reader to send the entire file. Once first record is in, map will start the processing, and then so on. Then second record will start, it will send to map, then third, then fourth, then so on. But map is not waiting for entire record to be written. Okay, so let's say the map got its first record 0, entire line, apple, banana, orange. Same will happen here. Now I will concentrate only on one flow. Same thing will happen on the second side. Second record 30, entire line. Now this map function has to be written by programmer. Okay, this is the map function. Above it, you don't need to write anything. Only you need to mention the format through which you want to read your file. Apart from that, will be taken care by the framework. This map function user has to write. So that's why, like, we just need to write our map and reduce function, and most of the things in distributed world, like in, we are not much worrying about, that is taken care by the framework itself. That's the like kind of beauty of framework. Like you're just concentrating on map and reduce function, and a lot of complexities related to the distributed programming, internet network communication, data transfer, sorting, shuffling, you don't need to worry about. Everything will be taken care by the framework. Now what map function we can write, since we have to keep two things in mind, key and value, right? Because framework only just understand key and value, right? So while writing our map function, we have to convert this input again into the key value pair. Okay, and in map function, as I said earlier, it is just a kind of transformation. We are just transforming something from one to other, or just reading few fields or whatever required. Okay, and this map will take input as a key value and output also as a key value. Okay, so now here we have a key as 0 and value as the entire record. Okay, so now I am not interested in byte offset because I have no business significance of this, so I will discard it. I am not going to read it. I am just going to read value, and I am going to value dot split on the basis of delimiter this one. Okay, and I can store in the array of string. Okay, so now I have each word apple, banana and orange stored in my string array, right? I have first element apple, second element banana, third element orange, right? So now I have everything. Now how I will make my key value? So I will make this word like apple as a key and value as a hard coded one. Apple 1, banana 1, orange one, because I have to emit in key value. I can't do anything else. I'm not going to do any counting here or grouping here or anything else. As I said, map is just a simple transformations. So I make key apple, since I already have stored in my array, so I can make it easily. Apple 1, banana 1, orange 1. This is the key value pair that I am going to emit from my map. This is with the record 1, right? And same thing goes with the record 2. But one thing we have to understand here, this map function works one record at a time. It is not working on two records at any point of time. And that's the reason we can't store any state or any variable or anything related to the earlier record that got passed from the map. So even though you have data stored in Hadoop cluster make up of terabytes or petabytes, you have to think only in terms of key value pair, first thing, and second important thing, you have to design your logic that works record by record. That is also another beauty of Hadoop. Even though you have petabytes of a data, you have to think only at record level. Okay, so two important point: map working one record at a time, so you can't store the value or state of any earlier record. You have to work on key value pair, right? And when designing or coding any logic, you have to think only at the record level. So I just thought about this first record. Okay, this is my first record coming, apple, banana, orange. How I'm going to emit my key value pair so that I can count in my reducer logic. So I have apple 1, banana 1, this is my first record. Second record will come, then I will add kiwi 1, apple 1, banana 1. And one more thing, key don't think as a primary key. Key is just a kind of notation. Okay, you can have any value in key. Key can be value, value can be key. I don't care what you pass. Okay, so if I have noted key, we will talk about later like what is the importance of this notation. But you can have anything in key, you can have anything in value. It's not like key has to be distinct or something. It's just a notation. Apple 1, banana 1, orange 1, kiwi 1, orange 1, banana 1. Since we can say we have two words repeated, no worries. Same will go here, parallelly it will run. So now, till now we are here, map task is executed. So now the output of this map, this is called intermediate output. This is running on data node 2, this is running on data node 1. It produces its own intermediate output, it produces its own intermediate output. And both will store their intermediate output in the local disk, which I already explained earlier. Local disk 1, local disk 2. Till now, I haven't transferred any data across the network. Okay, intermediate results are stored. Okay, so now my map task is completed on both of the data nodes. And this logic I have written, this map logic, user. Now I will come to framework. Let me draw a new diagram. Let me open a new page so that clear. Now I have intermediate result 1, intermediate result 2, local disk 2 stored, local disk 1 stored. Now again I have framework, Hadoop framework. What it will do? It will shuffle sort and group the data on basis of key, not value. So this is I was talking about, like you can store anything as a key, but here it will make a difference. The framework is doing shuffling, sorting and grouping on the basis of keys, not on values. Okay, so even though you can pass anything in key or value, but here it will make a difference. Framework work only on keys. So this, the data will be passed to the reducer. Okay, after sorting, shuffling and grouping, the data will be passed to the reducer, and number of reducers are configurable. For now I assumed, or my job, I have number of reducer equal to 1. Okay, and reducer is a very costly affair. It is very costly affair. Why? Because I have the mapper output from 1 on local disk. I have mapper output from 2 on local disk. Now I have to group the results, group the intermediate files of mapper 1, mapper 2. So data needs to be moved across the network, right? And this is just an example. For 2 mapper there will be lot of hundred or thousands of mapper running. So since I have reducer working on a global thing, or I have to work on this output as well, this output, data needs to be moved out. How it will move? And let's say we have a third node as well, and the reduce task needs to be started. Assuming you have reduce slot free here, reduce slot free here, reduce slot free here, but it really depends upon the job tracker where it really assigns the task. It may assign the reduce task here, reduce task here, or reduce task here. It won't make much difference, because anyhow now I have to move my data across the network. Okay, now it will go to the, let's say I have my reducer slot here free, and job tracker assigned the task to this slot. This output and this output will be sent to this slot, and before it is sent to the reducer, shuffling, sorting and grouping will happen. Now I will see what is shuffling, sorting. And shuffling means, since the data is moving across the network, so this process of collecting the map output into single machine is called shuffling. Since you are shuffling the data, right? We see here it was, let apple 1, banana 1, apple 1. Let's say in second record it was apple 1, banana 1, apple 1. Now I am collecting all the map outputs from mapper 1 here, mapper 2 here. This is called shuffling. Sorting, I will sort the data on the basis of keys. So apple 1, again apple 1, again apple 1. So whatever records we had with apple 1 will come first, then will come with the banana, whatever banana occurrences we have, then whatever kiwi occurrences we have, across all mappers. This is done at the global level. Okay, across all the mapper outputs. This is called sorting. And what is called grouping? Grouping means after this key is a one group, apple, and it will produce a list of values 1, 1, 1. This is called grouping, because you grouped on the basis of keys, and this is key and this value, list of values, whatever you had corresponding to your keys. Okay, so what will be the input to the reducer? Input to the reducer will be this key, and value is the list of values that was produced in our mapper output. So this is the key, this is value, this is one group, group number 2. Now reducer is working on groups in the same way mapper was working on record by record. Now we have made a group or in reducer, and then banana 1 1, kiwi 1. It produces a list of values and key as a grouping key. Okay, so now how it is passed to the reducer. So now I have one reducer, I have everything in my place. Now this sorting, shuffling, grouping, you don't need to worry about. Framework takes care. No need to write any code. This is default. Now you will write logic only in reducer. Now you already got the input as key, apple, and list of values. Key, banana, list of values. Now how you are going to count it? It's simple. You are going to write your own logic. Let's say you are going to put your enhanced for loop and t sum equal to 0 and t values equal to this list. Okay, and now you can have sum equal to sum plus this value. Okay, and now you will get the final output of a sum. Okay, so here what we are doing, you are counting the sum of values. Here this is the list, so this is the list, so 1 will be assigned first. Here you count 1, 0 plus 1 1, then 1 plus 1, then 2 plus 1, then it will be count, output will become as apple 3, banana 2, and kiwi 1. So this logic you have to write, reducer logic. Okay, so this is how you got the key and value, and now again you can give your output in key and value. And when what output you giving from reducer, now once you have the output as this, now you will write key as an apple and value as in 3, banana as a key and 2 as a value, kiwi as a key, 1 as a value. Now you have all the value, all the complete output what we wanted from our job. Okay, let me go one more, open one more page. Now out of reducer you got your output apple 3, banana 2, kiwi 1. Okay, this is global output now because I combined all mapper outputs. Now there will be a record reader, record writer. Now it will take again one record at a time, this one, this one, this one, and same like record reader, it will write the output in a file, in an output directory that you given at the time of when you submitted your job. You will give the input directory and the output directory. Input where you have the file which you want to get the count, output where you want to place your output file. Now in output directory it will write apple. By default, since we have a text, here we have a output format as text output format, it will keep tab as a delimiter, apple 3, banana 2, kiwi 1. Now this is the final output file stored in the output directory you have given with the file name of part-r50. So R means the output came out of reducer. Okay, one important thing to remember here is when you mention the output directory in when you submit your job, this directory should not exist before you submit your job. Okay, the map reduce job will create this directory and put this file. Why it is so? Because this map reduce is used for batch processing, which runs for long hours, since you have terabytes petabytes of a data. So if one program has already written their output, let's say in an output directory test, then you already have a data or output file, let's say after 10 hours of long run. And if another map reduce job is running and again creating the same directory, then the job will abort, because as a safety measure it doesn't want to overwrite the output result which you just received after 10 hours. So that's the reason Hadoop takes care. If the output directory exists before, it will abort your JVM, and the job will abort at the same time. It is a very initial check when you submit your job. It is not at the end. As soon as you submit it, it will abort it if output directory exists. Okay, and here, so this is how the MapReduce flow work in Hadoop. This is the kind of little bit low level, and there are more advanced concept when we read through partitioner, combiner and all, but this is the kind of basic flow how it goes through. And initially it may looks like a little bit tough, and it may be like how we are converting into key value, what should be our key, what should be our value, why we have such a long process to just get the count. You may have a lot of such questions, but believe me, once you start practicing and you see how it is working, like, you will see each and every problem can be solved through this key and value, because it's it because Hadoop provided a lot of input formats, lot of data types, and lot of configurable things. So even if you have some specific requirement, then you can still process your logic in the form of key values. So once you start looking at things, you will see like every problem can be solved through in the form of key value. So that's all for today. Thanks for watching my video, and if you like the concept, or comment it, and if you have any question, then let me know. Thank you very much.